All right, so let's finish this one up. Okay, so we had already talked about this. The or is only false when you have everything false. The rest is all true. So both of these, one was true, one was false. One was false, one was true. So I knew that they had to be true. Okay, now this is an and, right? So, and remember, and was true, and it's only true. You only have one true when you have all truths. And once again, I have one true, one false, one true. So I don't have both. So that means they can't be true. So they're both false. All right. Now this one is a typical setup for a truth table when you have multiple. You want to talk about everything that is possible. So we have two statements. They can either be both true, or the first one's true and the second one's false, or the first one's false, the second one's true, or they're both false. That's all the possibilities. So now we're going to take these guys and we're going to negate them, right? So all I'm going to do is change my two trues up here to false and my two false to true. So now I'm going to look at all the different ways that I could say not P and, remember this is an and, not P and Q. So remember, and is true only one time. And when is it true? When they're both true. So this one right here is the only one that should be true, right? All the rest of them should be false. And that is correct. Okay. All right. So we also have conditional statements. So a conditional statement is if P then Q statements. These are also called implications. And you use that little arrow and you read it, P implies Q. So P is sort of the if. If this happens, then Q is the then. So if this happens, then this is going to happen. Okay. If it rains, then my backyard's going to get flooded because that's what happens when it rains. Anyway, okay. So some people think of conditional statements as a promise. So I'm promising if it rains, I promise you my backyard is going to flood. Okay. So here's some examples. If you study, I promise you will pass. Okay. So if you study, then you'll pass. So you studied and you passed. So that's going to be true. Okay. What if you studied, but you did not pass? If you studied, but you did not pass, I broke my promise. So that one would be false. Okay. What if you didn't study, but you did pass? Now, I didn't make a promise that said, if you don't study, you will fail. That's not the promise. The promise is, if you study, you will pass. So if you don't study and you lucked out and you passed, that doesn't mean that I told you a lie. Okay, so that would still be true. This one, if you don't study and then you don't pass, again, that's not a promise. So the only one that's false is you studied, but then you didn't pass. Okay, so all of these are going to be true except for this one where you did what I asked, but then I didn't uphold my end of the bargain. Okay, so that's the only one that's going to be false. The first one is true, the statement is true, and then the conclusion is false. Okay. So we're going to practice writing these words that we see here in symbolic form. Okay, so the if you build it is going to be my P. It's going to be P. And then they will come is going to be my Q. Okay, so this one says if So if P, I could write then right here, but you don't have to, okay? If you build it, they will come. So that should be P, then Q. If P, then Q. If you don't build it, so build it is P, and don't build it, that would be the negation. Then they'll come. So that's going to be, if not P, then Q. We're not talking about whether this is true or false. We're just saying, we're just writing it in as a statement. Okay, if you build it, what's build it? That's a P again. So if you build it, they will not come. So see, that's my not, my negation. So that would be P, then not Q. Now this one is tricky. They will come if you build it. Do you notice that the if came second? Okay, but that doesn't mean that we have to write it second. We could say if you build it, they will come. So notice A and D is exactly the same. Okay, it's just they wrote it in a different order, but the if is still if you build it. And the second part is they will come. Okay, if you do not build it, so that's going to be the negation of P, they will not come. That's the negation of Q. So not P, then not Q. Or if they will not come, notice not come, that's my Q, okay? So if they will not come, then you did not build it. So we got to get used to writing these in symbolic form. You'll have that on your test where I'll give you some stuff. You've got to write it in symbolic form. Now there are three of these guys over here have a special name, okay? So one of them is called the converse. If Q, then P. If you build it, they will come. The converse is, if they come, you will build it. The inverse is, if not P, then not Q. So that is this one right. Let's see, let's do it in a different color. That's this one right here. Right, so that's my inverse. If you do not build it, then they do not come. And then the last one is the most important. That's why it is starred, okay? And that is, if not Q, then not P. So that one is, let's do that one a different color, maybe pink. Right? This is the most important. So if they will not come, then you will not build it, okay? Let's talk about, oh, did I talk about that? Yeah. Let me go ahead and go down here and talk about why that contrapositive is so important, okay? So logically equivalent, what logically equivalent means is you have two statements that are the same. You could, if you prove one, then it's like proving the other, okay? If you can't prove one of the statements, you could prove the other one instead. So this is used a lot when you are actually trying to prove something. If you're trying to prove something mathematically or logically and you can't get to it, you cannot prove it. If you can prove the contrapositive, then that is proof enough, okay? So the contrapositive is not Q, then not P. So if say, okay, so that is why I'm going to go back. So that is why this guy is so important, this contrapositive that we have up here for proving things, okay? All right, so we're going to state the converse, inverse, and the contrapositive. Okay, so the converse. So the original is, if x equals 3, then x squared equals 9. So the converse is going to be, if x squared equals 9, then x equals 3. Okay, so the converse was our Q, then P. Okay, now is that true? Okay, if x squared equals 9, then x has to be 3. That's not true because x could be negative 3. So that's not necessarily true, but that is the converse. Here's the next one, the inverse. If not, if x is not 3, then x squared is not 9. So that is not P, then not Q, right? Now, is that true? If x isn't 3, then if you square it, you're not going to get 9. Once again, if x is negative 3, when you square it, yeah, you do get 9. So that's not true. And lastly is the contrapositive, right? Which is not Q, then not P. So if x squared is not 9, then x can't be 3. And that is a true statement, okay? So let's do another one. If it snows, then classes are canceled, okay? So that's a true statement. If it snows, yeah, our classes are going to be canceled. If they even predict it, our classes are canceled. But let's say if it actually snows, classes are canceled. So the opposite would be Q, then P. So that would be if classes are canceled, it snowed. Well, that's not true because we had classes that were canceled because we had a tornado that ripped off the ceiling of the whole building, right? So they can be canceled and when it didn't snow. So let's do the inverse. The inverse is not P, then not Q. So that says if it doesn't snow, then classes aren't canceled. If it doesn't snow, then classes aren't canceled. Well, we've had classes canceled, tornado, water main break, all kinds of stuff where it didn't snow, but classes we then classes weren't canceled. Okay, contrapositive. If classes aren't canceled, then it didn't snow. That's true. If classes are not canceled, well, then we know it didn't snow. All right. So again, the only one that is the same as what we started with would be the same as this contrapositive. Okay. If this thing is true, we know this contrapositive is true. Okay. All right. So now we're going to talk about the chain rule. Okay. So in the chain rule, it says if P then Q is true, and then if Q then R is true, then if P and then R is also true. What in the world? Let's do an example. Okay. So here's one. If Sam is taller than Bubba, you see Sam there, and there's Bubba. So Sam's taller than Bubba. So if Sam is taller than Bubba, and Bubba is taller than Sue, Sue over there, then Sam is taller than Sue. Okay. Have you seen this in any other math class when they do things like this? Geometry. In geometry, they call this a transitive property. That's what it's called. Okay. All right, let's see if these guys are valid or not. All women are mortal. They're going to die eventually. Hypatia is a woman. So Hypatia is going to die. Hypatia is mortal. That is a valid valid argument. Okay. All rainy days are cloudy. So if it's a rainy day, it's cloudy. Well, today is not cloudy. So today, if it's not cloudy, then today is not rainy. That's a valid statement. Okay. Some students like skiing. Al is a student. So Al likes skiing. That's not true because it said some students, right? Some students like skiing. Al doesn't have to be one of those. Okay, so that's not a valid statement. So again, that's some things that you might be doing on your test, telling me if something is valid or not. Okay, so we've got just a little bit more in this section. Two more examples. Okay, this is called an Euler diagram. It's pronounced Euler. Okay, that's the teacher's name or the professor, doctor, mathematician's name. So Euler, it looks like Euler, but it's Euler. So he has a diagram. It looks a lot like a Venn diagram, doesn't it? Anyway, it's a tool used to determine the validity of an argument. So here we go. We want to look at this and talk about Miss Makeover. Do you see Miss Makeover? Right there's Miss Makeover. Okay. So Miss Makeover is a brunette. Miss Makeover a brunette? Well, look, Miss Makeover is in the blonde circle, so that's invalid, right? Miss Makeover is actually blonde. Miss Makeover has straight hair. Notice where the straight hair is. Right here is the straight hair. So, yep, it's valid. Miss Makeover does have straight hair. Miss Makeover is single. Well, if she was single, then Miss Makeover should have been over, over in here somewhere. But Miss Makeover was not. So that is invalid. Mr. Goodhearted is single with brown hair. Where would he be in our diagram? Single with brown hair. Well, in here is the single. So somewhere in here, we don't know about the brown hair part, but we know that he's going to be in that. He's going to be inside the single circle. Okay. Do any single people have blonde hair? Notice all the single people. Does it intersect? Does that circle intersect with the blonde? If it was like this, then yeah, but it's not. So nope, we don't have any single people with blonde hair. Do any single people have straight hair? Remember where our straight-haired people are. They're right here. There's no intersection. So nope. Do any single people have curly hair? Well, there's not a circle for curly hair. So we don't know. We don't know. They could all be bald for all we know. So anyway, okay, so that's an Euler diagram that we could use for an argument. So here's another one. For each of the following, form a conclusion. All college students are poor. Bubba is a college student. Okay, so those two are true. We know all students are poor. All college students are poor. Bubba's a college student. What do you know about Bubba? Yep, Bubba's poor. All right. All engineers need mathematics. Elroy doesn't need math. So Elroy is not an engineer. All bicycles have tires. All tires use rubber to make tires. So all bicycles must use rubber if you're going to make a bicycle. All right. We will do some more of these in class because there's a few little tricks that I need to show you.